Hey guys, so I'm making this video on a special request to sort of flesh out more the titration equations. While this video is included on level 5, it doesn't necessarily belong here. It belongs with really the titration equation level. So, but this is just a nice little refresher video on it. So hopefully it will help you better understand when to use which equation and how if you are having a hard time with that. So let's get into it. So far I mentioned 3 equations in all of our units so far. So they're based on the equations that are on your reference table. So I talked about the concentration equation, molarity equals moles over liters, and I talked about the titration equation and the titration equation with an extra little part to it. So let's write them all down and talk about them more. So the first 2 I have written, they are directly from your reference table. And then the third one is a variation on the second one. So to make things a little bit simpler for you guys, I would say instead of using the second one, just always use the third equation. I know the second one is the one on your reference table. All you have to do is tack on an n to both sides, and then boom, you have the third equation. And so I'm just going to cross out the second one. So you can always use the third equation when you're talking about titrations. And yeah, I'll explain in a second why the second equation doesn't have the n and the third equation does. And then I will retroactively talk about the first equation. So the reason why the second one and the third one are pretty much the same thing is the second equation is used for when you have a single proton acid, like HCl, reacting with a single hydroxy base, like sodium hydroxide. In this case, you have 1 mole of H plus ions, so your N is 1 here, and you have 1 mole of base ions, so your N is 1 there also. So you really don't have to write 1 on both sides, because the moles of your acid is 1, the moles of base is 1. It doesn't change your answer at all, so that's why this equation doesn't have N written in it. It's for the situations where you have 1 proton for 1 hydroxide base, they react 1 to 1, and it's simpler. But if you use the N and you just write 1 on each side for when that's the case, then that's fine too. They're going to cancel out, and 1 times anything is that thing anyway. So I always use this equation that has the N's in them, because when you have a situation where you have, let's say, HCl reacts with calcium hydroxide, now you still have for the acid your N equals 1, but for your base you have 2 hydroxides now. So on the base side your N equals 2. You have 2 moles of hydroxide ions and only 1 mole of acid ions. So for now the N's are really important in number 3, because your moles of acid, this will be a 1 here, but your moles of base here, that will be a 2, and that's going to affect the answer that you get when you plug in all the other numbers. So I like to keep the N's in there for the situation where it's not 1 acid to 1 base. So you would want to use this equation, your titration equation, whenever you're mixing an acid with a base. So if you have this is whenever you have the titration setup, where you have the burette, and it has a little stopcock, and it's attached to like this larger kind of platform, and you're titrating your known acid or base. This is what's known is in the burette. You're titrating that with an unknown concentration of acid or base in the beaker. So equation number 3 is going to help you for whenever you have this kind of situation where you're trying to figure out the concentration or the volume of an unknown acid or base by mixing it with another acid or base. So that is pretty much all of this unit is what we're doing for, we're using equation number 3. And so the times you would ever use equation number 1, molarity equals moles per liter, that's when you're just looking at one thing. So if you're just looking at, and I'll just kind of make a divide here, that's when you're only looking at an acid or only looking at a base. You're not mixing a known acid or a base. Let's say this is the acid, and let's say this is the base. Here you're mixing two different things, acid and base, which is why you have acid here and base here. For this equation, you could be using it only when you're looking at an acid or only when you're looking at a base. You're not mixing different things. So like, for example, let's say I know I have an acid that has a concentration of 2 molar. And I know that I have it in a beaker and its volume is, let's say, 2,000 milliliters. Let's make it easier. Let's just say it is 2 liters. So it's in a beaker that's 2 liters. And I want to know how many moles of acid are in that container. I could just solve for x by multiplying each side by 2, and then the 2's cancel, and then I multiply this side by 2 liters. 2 times 2 is 4, so I have 4 equals x. So I found out that my moles, because that was the x, I have 4 moles of acid. So this was all for just acid. You could have said instead, I have 2 molar base in 2 liters, how many moles of base do I have? So you'd be solving it for only one, either an acid or a base. You're not mixing anything. You just have a container that has an acid or a base in it, and you're trying to find out either the concentration or the moles. So this equation, number 3, is for mixing. Number 1 is not mixing, it's just looking at a specific acid or a specific base and calculating its moles or concentration. You usually know what the volume is, but you could solve for volume too. So here is a problem I have. I say make a 3 molar solution of HCl, hydrochloric acid, in, let's say, 4 liters. So I would want to use for this, I'm only talking about the acid, and so I'm not titrating, I'm not mixing 2 different things, so I would want to use this equation to solve for it. So I have my molarity equals moles over liters. I know the molarity is 3 molar, and I know the volume I'm making it in is 4 liters. So to solve for moles, I multiply both sides by 4, and it cancels here, so 4 times 3 is 12. So I have 12, oh, what did I do? I have 12 moles of acid. And so by knowing that I need to put in 12 moles of acid, that makes it easier for me to actually do, because I could figure out how many grams are in a mole using the periodic table. So yeah, that is an example of one of them. And I have class now, so I will give you an example of when to use the other equation in just a second.